This is Senior Algebra Section 7.2, multiplying and dividing rational expressions. So today we're multiplying and dividing here. So let's review a little bit. In the first one here, multiplying fractions. Again, you've done this before. We could multiply straight across. 3 and 5 is 15, 10 and 9 is 90. And then from there, divide out the top and bottom by the same term. What goes into 15 and 90? Well, 5 does. And we get 3 over 18. And then what goes into 3 and 18? Well, 3 does. So if I divide the top by 3 and the bottom by 3, I get 1 over 6. So that's one way to do it. However, we're going to look at a little bit different way to do it. Instead of multiplying everything together, we're just going to break things up, and since we are multiplying, we can cancel stuff out. That's the same on the top and bottom here. So I'm going to write 10 as 2 and 5. I'm going to write 9 as 3 and 3 here. So I really have 3 times 5 and 2 times 3 times 3 times 5. So if I look, since I am multiplying everything on the top, multiplying everything on the bottom, I can cancel stuff out. So what's the same on the top and bottom? The 3's and the 5's here. So what does that leave me? A 1 on top and 2 times 3, or 6 on the bottom. Now when we're doing typical fractions with just integers, constants, that type of stuff, either way is effective. However, when we start doing rational expressions that have variables in it, tends to be a little bit easier not to multiply everything together here. So x squared, we know that's x times x, and then we have 12 times x. Now again, 12 we can write as 2 times 6. Everything's being multiplied, so 6's are going to cancel out, and the x's are going to cancel out. Again, everything here is being multiplied, so that's why I can cancel stuff out. What am I left with? On top, an x. On the bottom, 2x. Oh, should be a 2x. Oh, no, just a 2, I'm sorry. So I have x over 2. In C, if I look, I am not going to put them together. I'm just going to leave it as x plus y, quantity squared on the bottom, and x plus y on the top, x squared on the top, and 2x on the top. So I'm going to write x plus y squared as x plus y, x plus y. Notice, since I am still multiplying everything here, yes, that's a plus, but that whole thing, x plus y, is being multiplied by x squared. So that whole thing, that one thing, is being multiplied there. So I can cancel those out. Well, x squared we know is x times x. So I have that x on the top, that x in the bottom can cancel out. I'm going to be left with an x on the top, on the bottom a 2, and x plus y. At this point you're done. You don't have to distribute the 2 back in. You could if you wanted to, but not necessary. So that brings us into the much more complicated ones here. So in this one, don't multiply everything together. Don't multiply the tops together. Don't multiply the bottoms together. Factor. Look to factor here. So on the top one, I'm going to take out an x, and then I'm going to factor each part separately, and then I'm going to take a look here. I cannot just cross out the x's here, because it's x squared plus 3, x squared minus 3, x minus 4. I can't just cross those out. I have to factor everything to get everything to be multiplying together. So I factor the bottom, x minus 4x plus 1. I'm going to factor the top, x minus 4, x minus 1. And on the bottom, x plus 3, x minus 1. So now that I have everything factored here, I'm just going to put things together. Now this is kind of a intermediate step here. Not necessarily, but it does help some people here. So what do I have? I have x plus 3, x minus 4, x minus 1 on the top. On the bottom, x minus 4, x plus 1, x plus 3, and x minus 1. Now I'm going to start looking what is the same on the top and bottom. Well, x minus 1, x minus 1, x plus 3, x plus 3, and the x minus 4 and the x minus 4. So what am I left with? On the top, just an x. On the bottom, x plus 1. We can do the same thing with multiplying here, or with dividing, which we'll do next. So again, you know, that intermediate step, not necessary. You could just start canceling stuff out from there. That'd be okay too. That's your choice. You'd still be left with the x and the x plus 1. So either way. So in example 3, we divide. Now let's recall, how do we divide fractions? We multiply by the reciprocal. So it's 5/8 multiplied by the reciprocal of 7 over 16, which is 16 over 7. Now again, we could multiply these across, or we could break 16 up into 2 and 8, and then look to see what cancels out. I chose 2 and 8 instead of 4 and 4 simply because I see there's an 8 on the bottom. The 8s are going to cancel out. So I may be left with, on the top, 10. On the bottom, 7. So in B, now, before I start multiplying and doing that stuff, I'm going to flip it. Okay, remember, it's dividing here, so I'm going to rewrite it as x squared minus 4 over x squared minus 1. And then I'm going to multiply by the reciprocal. On the top, I'm going to have 1 minus x. On the bottom, 2x squared plus 4x. At this point, I'm going to factor everything. So x squared minus 4, that's a difference of 2 squares. There is no middle term, so that's going to be x plus 2, x minus 2. On the bottom, same thing. X squared minus 1 is going to be x minus 1, x plus 1. On the top, 1 minus x, that just stays there. And then I'm going to take a 2x out of the bottom. So I'm going to have 2x and x plus 2. At this point, what's going to cancel out? The x plus 2's are going to cancel out. Now, something to look at here. I have 1 minus x and x minus 1. They're opposites here. So I'm going to take a negative out of the 1 minus x on the top. So I pull out a negative 1. When I pull out a negative 1, I have negative 1 plus x. And that's the same thing as x minus 1 here. So now, these two are the same. They are going to cancel out. So those two things cancel out. What am I left with on the top? Negative 1 times x minus 2. On the bottom, 2x and x plus 1. At this point, you could leave it like that, or if you wanted to put the negative back into it on the top, you could, and write it as negative x plus 2 all over 2x times x plus 1.